So you can see my screen now. ओके जी, कोई सवाल है अगर प्रीवियस लेक्चर से तो प्लीज़ पूछ लीजिए। एज यू नो, आपके फाइनल एग्जाम्स की डेट अनाउंस हो चुकी है। दे विल बी स्टार्टिंग इन द थर्ड वीक ऑफ February। सो इस वीक के बाद हमारे पास एक वीक और है एंड देन यू विल बी गोइंग फॉर योर फाइनल एग्ज़ाम। फाइनल एग्ज़ाम के लिए जो हमारा सिलेबस है वो उस सब पर मुश्तमिल होगा जो हम पढ़ लेंगे फाइनल एग्ज़ाम स्टार्ट होने से पहले तक। यानी एक हमारी आज क्लास हो रही है एंड देन देयर विल बी 2 मोर इन द नेक्स्ट वीक। सो उन 2 क्लासेस तक जो कुछ हम कवर करेंगे दैट विल बी ऑन योर फाइनल एग्ज़ाम। एंड वन थिंग अबाउट दैट कि जो मेड का पोर्शन होगा वो इसके अंदर इंक्लूडेड नहीं होगा। सो जो कुछ हमने फाइनल में पढ़ा, आप यूँ कह लें कि जो हमारा सेकंड कोर्स है इन्फरेंशियल स्टैटिस्टिक्स के ऊपर, प्राइमरीली दैट इज़ द कोर्स दैट विल बी पार्ट ऑफ योर फाइनल एग्जाम। फॉर्मेट भी उसका जो है वो बता दिया गया है। प्राइमरीली इट इज़ अज्यूम टू बी विद 20 MCQs, सो वी विल गो विद 20 to 25 MCQs, and the rest will be like mixed questions. Okay, so we start today's discussion then. So आज हम एग्जाम्पल देखेंगे setting up a test of difference in population proportions. So we talked about proportions, so now we will be talking about difference in the proportion. So again, we take a look at the example of the CS Mott Children Hospital conducting a national poll on water issues in children health, water and safety. We will be looking at an example about swimming lessons. So the question that we have at our hand is there a significant difference between the population proportions of parents of black children and parents of Hispanic children who report that their child has had some swimming lessons? तो अब हमारे पास दो रेसेस हैं, ब्लैक और हिस्पैनिक, और उन बच्चों के पेरेंट्स से जो डेटा कलेक्ट किया गया है उसकी बेसिस के ऊपर हमें इस क्वेश्चन का जवाब देना है कि क्या दोनों के प्रोपोर्शंस में इस सिग्निफिकेंट डिफरेंस है या नहीं है, राइट? So in this case, the population that qualifies for this research question is all parents of black children aged 6 to 18 and all parents of Hispanic children aged 6 to 18. जी, are you saying anything to me? You people can see my screen and hear me? Okay. So all parents of black children of that age and all parents of Hispanic children of that age qualify for to be included in the target population for this research question. And the parameter of interest is the difference in the proportion. So हम कहते हैं कि P1 minus P2 will be our parameter of interest, where one subscript represents the black and 2 represents द हिस्पैनिक पेरेंट्स। तो जो प्रोपोर्शन ब्लैक पेरेंट्स का है जो ये रिपोर्ट कर रहा है कि उनके बच्चों ने स्विमिंग लेसन्स लिए थे, उसके प्रोपोर्शन में से हम हिस्पैनिक चिल्ड्रन के पेरेंट्स जो प्रोपोर्शन रिपोर्ट करते हैं उसको सब्ट्रैक्ट कर लेंगे और इसका डिफरेंस जो है वो हमारा फोकस होगा इस पर्टिकुलर एग्जाम्पल के अंदर। ओके, so now we need to test for a significant difference in the population proportions of parents reporting that their child has had swimming lessons at the 10% significance level. So इस एग्जाम्पल में अगर आप देखें तो हमने ये डिसाइड किया है कि हम बेसिकली इसको 10% सिग्निफिकेंस पे देखेंगे और हमें देखना क्या है कि क्या दोनों पॉपुलेशन के प्रोपोर्शंस में कोई सिग्निफिकेंट डिफरेंस है या नहीं है. So as usual, we first form our hypothesis, right? So the default hypothesis or the null hypothesis or H naught that we formulate is that P1 minus P2 is equal to 0. That there is no significant difference in the proportions of black and Hispanic parents reporting that their children had some swimming lessons. राइट. सो हम अपना डिफॉल्ट हाइपोथेसिस या नल हाइपोथेसिस जो है वो P1 माइनस P2 इज इक्वल टू 0 पे सेट कर लेते हैं. And the alternative hypothesis now is that P1 minus P2 is not equal to 0. अच्छा, अब यहाँ पे एक टेंडेंसी हो सकती है कि हम यहाँ पे नॉट इक्वल इस्तेमाल करें, ग्रेटर देन इस्तेमाल करें या लेस देन इस्तेमाल करें. सो दैट विल कम फ्रॉम द टाइप ऑफ क्वेश्चन दैट वी आर हैविंग, राइट. अगर ये सवाल ये होता कि क्या P1 का प्रोपोर्शन P2 के मुकाबले में सिग्निफिकेंटली ज़्यादा है, तो हम कहते हैं P1 माइनस P2 ग्रेटर देन 0. और अगर हम ये कह रहे हैं, हमारा सवाल ये होता है कि P1 का प्रोपोर्शन P2 के मुकाबले में सिग्निफिकेंटली कम है, तो हमारा रिसर्च क्वेश्चन जो है वो हाइपोथेसिस इस केस में होता है P1 माइनस P2 लेस देन 0. लेकिन हमारा सवाल ये है कि क्या इनमें कोई सिग्निफिकेंट फ़र्क है, वो बड़ा है या छोटा है, कोई इट डजंट मैटर. हम सिर्फ ये नोट करना चाहते हैं कि क्या इनमें फ़र्क है. So that's why the research question is P1 minus P2 equal not 0. Okay, and the significance level that we have narrated in our setting is 10% or 0.10. That is the value of alpha for this hypothesis test. So moving on, we go for the data collection, and then the data that we have collected is basically comprised of 247 parents of black children and 308 parents of Hispanic children, right? और 247 पेरेंट्स जो ब्लैक चिल्ड्रन के हैं उनमें से 91 ये रिपोर्ट करते हैं दैट देयर चिल्ड्रन हैड स्विमिंग लेसन्स, और जो 308 हिस्पैनिक चिल्ड्रन हैं उनमें से 120 ये रिपोर्ट करते हैं दैट देयर चिल्ड्रन हैड स्विमिंग लेसन्स. ओके, now we talk about the assumptions. We need to assume that we have two independent random samples. हम ये assume करते हैं कि हमारे पास दो independent random samples हैं. इससे मुराद क्या है कि ये जो हमने दो रिजल्ट सर्वे रिजल्ट्स यहाँ पे रिपोर्ट किए हैं, so one is this sample which is basically comprised of the parents of black children, and then there is another sample which is basically comprised of the parents of Hispanic children, and both these samples are random and independent, right? The second assumption that we have is that we also need large enough sample sizes to assume that the distribution of our estimates is normal. So that is, we need n1 in n1 p hat in and n1 1 minus p hat, n2 times p hat, and n2 times 1 minus p hat to be all at least 10. अच्छा, अब इस केस में हम क्या कहते हैं, we need to estimate the common proportion and then make sure that we would expect at least 10 yeses and 10 no's in each sample. So हम इसमें से बेसिकली करते क्या है, हमारे पास जो कि दो सैंपल्स हैं, तो हम दो सैंपल्स में से कॉमन प्रोपोर्शन निकालते हैं यस का, दैट इज 91 ब्लैक पेरेंट्स और 120 हिस्पैनिक पेरेंट्स ने रिपोर्ट किया दैट देयर किड्स हैड स्विमिंग लेसन्स, और उनकी टोटल पॉपुलेशन जो इसके इस सैंपल के अंदर है वो है 247 प्लस 308. So that turns out to be 211 divided by 555, where 211 parents reported that yes, their children had swimming lessons, and the total parents were 555. So that is 0.38. The common proportion that narrates that their children had swimming lessons is 0.38, right? And now basically we say that based on this common proportion, अगर हम इसके slices देखें तो 247 का 0.38 94 है और 247 का 1 minus 0.38 153 है. Similarly 308 का 0.38 117 है, और 1 minus 0.38, that is obviously 62%, that is 191. So all the groups have a sufficient number of cases reported in those. So in this assumption, if this assumption is not met, we can perform different tests that bypass this assumption. But for this case, this assumption holds. We have sufficiently large data available for our series. Now the best estimate of the parameter, that is P1 hat and P2 hat. So for P1 hat, we have 91 parents of black children reporting that their children had swimming lessons. So that turns out to be 0.37. और फिर P2 hat है हमारे पास, जिसमें हम हिस्पैनिक पेरेंट्स की बात कर रहे हैं, हिस्पैनिक चिल्ड्रन के पेरेंट्स की बात कर रहे हैं, जो 308 में से 120 ये रिपोर्ट कर रहे हैं that their children had swimming lessons. So it turns out to be 120 by 308, that is 0.39. And then we talk about the difference between P1 hat and P2 hat. And that difference is 0.37 minus 0.39, and that is minus 0.02. So apparently looking at this, we get to know कि जो difference है proportions में वो -0.02 है. So what is your bare idea out of this difference that you notice here? Is this significant? Is this small, or what? Okay. So this difference turns out to be -0.02, which is rather small. Now we go for our test statistic. So the test statistic that we have revealed for hypothesis test in this case is that we take best estimate and we subtract the hypothesized estimate out of that, and we divide it with the standard error of the estimate. So हमारा best estimate जो था, that is represented by P1 hat minus P2 hat. So जो proportions का difference हमने compute किया है, और हमारा हाइपोथेसाइज्ड एस्टिमेट था कि P1 माइनस P2 हैट, P1 और P2 का जो डिफरेंस है वो 0 है. सो वी सब्ट्रैक्ट द हाइपोथेसाइज्ड एस्टिमेट व्हिच इज 0 from the best estimate, which is P1 minus P2 hat, which has turned out to be minus 0.02 in this case that we just computed. So the error on that term will be computed using P hat into 1 minus P hat into 1 over N1 plus 1 over N2. So that basically is कि आप proportions का जो error compute करते हैं बिल्कुल उसी तरीके से इसको compute कर रहे हैं. The only difference is that you have two different samples, N1 and N2. अगर आपके पास एक ही sample हो तो आप इसको simply P hat into 1 minus P hat over N and the square root of whole के तौर पे लिख सकते हैं. So now we plug in the values in this equation. So we get like P1 hat minus P2 hat we know is 0. Let me just does it no. Okay. Okay, so we plug in the values P1 hat minus P2, that is minus 0.02 as we computed earlier. उसमें से हम 0 सब्ट्रैक्ट करते हैं तो ये टर्म वही रहती है minus 0.02, और फिर ये वैल्यूज इसके अंदर प्लग इन करके जो हम एरर टर्म कंप्यूट करते हैं that turns out to be 0.041, and when we perform this division this turns out to be minus 0.048, right? सो बेसिकली जो z स्टेटिस्टिक हमने कंप्यूट की है अपने हाइपोथेसिस को टेस्ट करने के लिए वो आती है -0.48. So can anybody say anything how to interpret this statistic? Can you people hear me? आवाज आ रही है आप लोगों को मेरी? Hmm. So would you like to say anything about this z score that we have computed minus 0.48? Okay, you choose not to. That's okay. Okay, so what does it mean if the z value is minus 0.48? So we have like interpreted it a number of times already in the previous examples. So that means that our observed difference in sample proportions is 0.48 estimated standard errors below our hypothesized mean of equal population proportions. तो हमने हाइपोथेसाइज ये किया था कि दोनों पॉपुलेशन के proportions में डिफरेंस नहीं है, ठीक है। अब जब हमने इसका जी स्कोर कंप्यूट किया तो उसकी एक पर्टिकुलर वैल्यू आई हमारे पास जी। ओके, सबको आवाज कटी कटी मिल रही है या? ओके, okay, so there is some fluctuation. Okay, let's just hold for a second. Okay, it was maybe because of a bit of power fluctuation. The internet speed is quite good. That shouldn't be a problem. The upload speed is also quite good, so that shouldn't be a problem. So, are you able to hear me now? Okay. Okay, so what does z equal minus 0.48 mean? That means that our observed difference in sample proportion is 0.48 estimated standard errors below. हम below क्यों कह रहे हैं? Because it is minus. Had it been positive, we would have said above. आर हाइपोथेसाइज्ड मीन। हाइपोथेसाइज्ड मीन क्या था? जीरो। हमने ये अज्यूम किया था कि दोनों पॉपुलेशन प्रोपोर्शंस का जो डिफरेंस है वो जीरो होगा, उनमें कोई डिफरेंस नहीं है, राइट? सो वी हैव विटनेस्ड सम डिफरेंस, बट हाउ मच इज दिस डिफरेंस? ये जो डिफरेंस हमने ऑब्जर्व किया है ये एक्चुअली कितना है? सो दैट इज व्हाट वी नीड टू टॉक अबाउट नाउ। ओके, बेटा अपना माइक बंद कर दें। ओके, सो बेसिकली अब हम बात करते हैं कि ये जो 0.48 हमने मेजर किया है, ये बेसिकली व्हाट डज इट टर्न आउट टू बी? इस डिफरेंस का मतलब क्या है, राइट? सो बेसिकली हम ये जानते हैं कि ये जो z वैल्यू हमने मेजर की है, वी हैव टॉक्ड अबाउट इट दैट दिस आल्सो फॉलोज अ नॉर्मल डिस्ट्रीब्यूशन, राइट? सो नॉर्मल डिस्ट्रीब्यूशन का मतलब ये है कि the mean will be zero and the variance or the standard deviation will be one in this case, right? So अब हम इसको अगर इंटरप्रेट करने की कोशिश करें, 0.4 माइनस 0.48 जो है इसकी p वैल्यू क्या बनती है? वी कैन गेट दैट p वैल्यू व्हिच बेसिकली टर्न्स आउट टू बी लाइक 0.63। हाउ डू वी बेसिकली गेट इट? इट्स बेसिकली अगेन लाइक अगर हम we have like anything like comment, yeah. So it's basically like this, that you have a it's not happy with it. Sorry, I'm not able to draw it. So this is like this, right? So first करेंगे line सीधी है. So this is point where we have like kind of zero kind of thing, right? And then we will have like 1 here, and similarly -1 here, and so on, 2 here, and so on, right? So the values will be distributed like that. Now what does it mean to be minus 0.48? Minus 0.848 would be like somewhere here. It will be minus 0.48, right? So that means minus 0.4 is here, so this is the region that we are basically talking about. And since in this case we have not specified कि हमारा पॉपुलेशन प्रोपोर्शन एक दूसरे से ज़्यादा है या एक दूसरे से कम है, इसका मतलब ये है कि हमें बेसिकली दोनों साइड्स इसकी देखनी होगी. सो वी सी माइनस 0.48 एंड वी ऑल्सो सी प्लस 0.48, like this one, right? So this is basically like going from this point to this point, and how awful it is in drawing things. Okay, but anyway, so this is the proportion that we are looking for, and this is the proportion that we are looking for. And if you find the value of it from the table, that the p value for this proportion would turn out to be 0.63, and 0.63 is significantly larger than 0.10, which is the value of alpha. So हमने जो significance तय की थी इस test के लिए, that was 0.10, right? So that means that the p value that you have got is significantly larger than the significance that you had associated with this test, which was 0.10 or 10%. That means we failed to reject the null hypothesis. That means we don't have evidence against equal population proportions. हमारे पास ऐसा एविडेंस नहीं है जिसकी बुनियाद पे हम ये कह सकें कि हमारे पॉपुलेशन प्रोपोर्शंस इक्वल नहीं है. So formally, based on our sample and our p-value, we failed to reject the null hypothesis. We conclude that there is no significant difference between the population proportion of parents of Black and Hispanic children who report their child has had swimming lessons. अब ये जो बात हम कह रहे हैं कि हम इस हाइपोथेसिस को रिजेक्ट नहीं कर सकते, इसका मतलब ये नहीं है कि हम किसी अल्टरनेट हाइपोथेसिस को के ऊपर जो है वो हम कंसिडरेशन लेके जाते हैं। दैट सिंपली मीन्स कि हम इक्वलिटी के हाइपोथेसिस को रिजेक्ट नहीं कर सकते। सो हम अनइक्वलिटी को एक्सेप्ट कर रहे हैं या नहीं कर रहे हैं, दैट्स अ डिफरेंट थिंग, राइट? Okay, now one like sideway thing is that there can be situations where we have concerns, where we could have some kind of concerns about the assumptions or the kind of test that we want to lay out. So like यहाँ पे जो आपको एक टू वे टेबल नजर आ रहा है जहाँ पे हमने uh, यहाँ पे सम लिया, स्विम लेसन्स और नो स्विम लेसन्स का सम इधर आ गया, और सिमिलरली दोनों पॉपुलेशन के अक्रॉस जो हमारे सम आते हैं स्विम लेसन्स और नो स्विम लेसन्स के, वो भी हमने यहाँ पे ले लिए। टोटल ऑफ ऑल द पॉपुलेशन इज 555. So for example, we could be interested in testing two-sided hypothesis, and that will still lead to the same conclusion. So we could use, for example, something like chi-square test. We are not going to the details of chi-square test. Or in some situations, we could be basically modeling things on different measures. So this is basically allows one side hypothesis typically for small samples. So when small sample sizes are very small, so we could go with this Fisher's exact test. So these are two alternative tests available to the conventional hypothesis test approaches, which have their strengths and weaknesses. We will not be covering them, but just to mention that different approaches do exist. So chi-square is one, and Fisher's exact test is also one of those approaches. So primarily, this is what we talked about in this particular example, that we had a hypothesis which was basically centering around के दो पॉपुलेशन प्रोपोर्शंस हैं, और उन दो पॉपुलेशन प्रोपोर्शंस के जो डिफरेंस है हम उसके ऊपर, वो हमारा पैरामीटर ऑफ इंटरेस्ट था, एंड देन वी टेस्टेड if there is a significant difference, and we formulated the hypothesis with 10% significance level. So our null hypothesis was P1 minus P2 has no difference. They both are the same or equal to 0, and the alternative hypothesis was that they were not equal to 0 with significance level 10. And then we mentioned our survey results. We tested if we had enough data, and then we tested the proportions, and we got the value for the difference in P1 and P2, which was 0.02. And then we went on to perform the hypothesis test on that. So we formulated it as best estimate minus hypothesized estimate, and we divided it with the standard error of the estimate, and the value we got was minus 0.048. And that means कि जो हमारा डिफरेंस है वो 0.48 एस्टिमेटेड स्टैंडर्ड एरर्स बिलो है हाइपोथेसाइज्ड मीन के। सो इसका मतलब जो है वो बेसिकली हमने ये बताया कि हम बेसिकली दोनों साइड्स के ऊपर का जो एरिया है उसको देखने में इंटरेस्टेड हैं, एंड दैट टर्न्स आउट टू बी, द पी वैल्यू टर्न्स आउट टू बी 0.63, which is significantly larger than 0.10, and that means we failed to reject the null hypothesis, or we can say that we don't have enough evidence against the equal population proportions. अच्छा, अब इस चीज़ को आप इंटुएटिवली अगर देखें, बिकॉज ये तो एक स्टैटिस्टिकल टेस्ट है जो हमने परफॉर्म किया, अगर आप इंटुएटिवली देखें तो यहाँ पे हमें जितना डिफरेंस नज़र आ रहा है, दैट इज 37% पेरेंट्स ब्लैक चिल्ड्रन के ये रिपोर्ट कर रहे हैं that their children had swim lessons, और 39% parents Hispanic children के ये report कर रहे हैं that their children had swim lessons. So based on these raw figures, we could have an intuition into it that what would it really turn out to be. इसकी वैल्यू अल्टीमेटली क्या होगी. So apparently there isn't a huge difference, and our statistical test, the hypothesis test, has also revealed or stamped the same thing. Okay, next we are going to talk about testing hypothesis about a population mean. So हमने population proportion के ऊपर hypothesis test perform किया, population proportion के difference के ऊपर hypothesis test perform किया, अब हम population mean और फिर उसके बाद mean के difference पे भी हम जाके बात करेंगे. So we will be testing the hypothesis about a population mean now. Just hold on. Assalamualaikum. जी। पता नहीं, मैं तो घर पे नहीं हूँ। जी। ठीक। ठीक। ओके। Okay. So now we are going to test hypothesis about a population mean. So the population mean, again, we use the example of cartwheel study, which was basically 25 team members or colleagues, all adults, were asked to perform a cartwheel. The variable of interest in this case is cartwheel distance in inches for each individual that we see here. And the research question is the average cartwheel distance in inches for adults more than 80 inches? ये इसका नाम क्या है? अनवांटेड वीडियो, ये जो क्या कहते हैं इसे, ये बेजन साहब को डिफरेंट वीडियो के नाम से जो हमारे पास एडेड है। ये साहब कौन है? डिफरेंट वीडियो। कैन यू रिकग्नाइज हिज फेस? हु इज हिम? ओके, ही इज इन इवनिंग नाउ, राइट? ये भी आपकी क्लास के हैं, हमाद गोपांग? ओके। 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 Okay, good enough. So, is the average cartwheel distance for adults more than 80 inches? इनके जो अडल्ट कार्टव्हील डिस्टेंस तय करते हैं, क्या उसकी एवरेज 80 इंचेस से ज़्यादा है? सो दिस इज द रिसर्च क्वेश्चन. So the population of interest in this case would be all adults, because we are wanting to perform this study on the adults, and the parameter of interest is the population mean cartwheel distance, or that is represented by mu. And we perform a one sample test regarding the value of the mean cartwheel distance for population of all such adults. So we will be having one sample, और हम उसके लिए जो population mean है उसको मुहैया करने में interested होंगे. So now the step one is to define the null and alternative hypothesis. The null hypothesis for us is that population mean cartwheel distance is 80 inches. So we always assume the other side of that. And the alternative would be that the population mean is greater than 80 inches. That is what is coming from the question. हम हमेशा जो null hypothesis है और alternative hypothesis है वो अपने research question में से ही formulate करते हैं. So हमारे research question के मुताबिक हम ये जानना चाहते हैं that is the average cartwheel distance for adults मोर देन 80 इंचेस, क्या एवरेज कार्टविल डिस्टेंस जो अडल्ट तय करते हैं वो 80 इंचेस से ज़्यादा है, तो हमने नल हाइपोथेसिस क्या लिया कि नहीं 80 इंचेस ही है, और अल्टरनेटिव में रख लिया कि ओके इट इज़ मोर देन 80 इंचेस. So now we will be like trying to test that is there is significant evidence to reject the null hypothesis and assume that yes it is more than 80 or no. Now, in more compact notations, we will be saying that H naught or the null hypothesis is that mu is equal to 80, and the alternative hypothesis is that mu is greater than 80. And the significance level, say for this case, is हम 5% रख लेते हैं, 5% पे टेस्ट करना चाहते हैं. So where mu represents the population mean cartwheel distance for all adults. Now, the second step in testing this hypothesis is to examine the results, check the assumptions, summarize data via test statistic. So, हमारे पास observations 25 हैं. We have only 25 observations for this particular example. And the minimum value that we have recorded in this particular data is 63 inches. जो सबसे कम कार्टव्हील डिस्टेंस हमने ऑब्जर्व किया है वो 63 इंचेस है, और जो सबसे ज़्यादा कार्टव्हील डिस्टेंस हमने ऑब्जर्व किया है वो 115 इंचेस है. और इन 25 ऑब्जर्वेशंस का जो मीन है हमारे पास वो है 82.48, and the standard deviation is 15.06. Now looking at this current mean, इस mean को देखकर हमारा जो null hypothesis है और alternative hypothesis है वो दोनों हमें मालूम है that the null hypothesis says that the average cartwheel distance is essentially 80, and the alternative hypothesis is though that no, it is more the mean of the cartwheel distance is more than 80. Now, looking at our observations, the mean that we have got is 82.48. So, what do you say about हमें हमने अभी तक hypothesis test नहीं किया, हमने अभी तक अपनी टेस्ट स्टेटिस्टिक को कंप्यूट नहीं किया, but based on this raw data that we have seen and we have seen the mean of that, what do you think, what do you reflect of it, or what do you make of it, that आपको क्या लगता है कि आप अल्टरनेटिव या नल हाइपोथेसिस में से किसके बारे में क्या राय रख सकते हैं? आवाज आ रही है मेरी आपको? Okay, so you feel that looking at this, you will be tended to think that you might reject the null hypothesis. This is what you're saying? Okay, so what is the motivation in that? Why do you feel that you might tend to think to reject the null hypothesis based on the mean value that you have seen, which is 82.48? तो आपको क्यों लगता है कि शायद हम null hypothesis को रिजेक्ट करने के बारे में सोच सकते हैं? The bare idea is that if we see the value only, this value, the mean value, okay, this mean value is bigger, bigger than what we have listed in the hypothesis, that is 82.48, right? So 82.48 is obviously bigger than 80. But how bigger it is? And does it mean that it is consistently bigger? देखिए हमने एक सैंपल लिया है जो कि 25 अफराद पर मुश्तमिल है. सो अगर हम रैंडमली इस चीज़ को सोचें तो वी कैन कीप ड्राइंग दीज सैम्पल्स जिसमें जो मीन होगा वो ज़ाहिर वेरी करेगा. समटाइम्स दिस मीन कैन बी ग्रेटर देन 80, समटाइम्स दिस मीन कैन बी लेस देन 80. सो बेसिकली हम महज इस लिटिल इंक्रीज इन द वैल्यू को देखकर ये चीज़ तय नहीं कर सकते कि हाँ हम अल्टरनेटिव हाइपोथेसिस के साथ चले जाते हैं और नल हाइपोथेसिस को रिजेक्ट कर देते हैं. वी बेसिकली हैव टू मेक श्योर, हम स्टेटिस्टिकल एनालिसिस जो इसका कर रहे हैं उसका पर्पस बेसिकली ये है कि हम इस बात को यकीनी बनाना चाहते हैं कि जो हमारी अजम्पशन है डेटा के बारे में वो उसके अंदर जो रैंडम वेरिएशंस आती हैं, ज़ाहिर है हम एक सैंपल लेंगे उसके अंदर ये मीन डिफरेंट हो सकता है, दूसरा सैंपल लेंगे उसके अंदर ये मीन डिफरेंट हो सकता है, ये कभी 80 से ज़्यादा हो सकता है, कभी 80 से कम हो सकता है. जबकि हम ये कहना चाहते हैं कि क्या ये 80 से ज़्यादा ही होता है. So that will not be a plain yes no answer. We will have to do some analysis on that, right? So that's why merely हम इसको 82.48 को देखकर ये नहीं कह सकते कि हम इसको रिजेक्ट कर देंगे null hypothesis को, right? Although it is slightly bigger than what we are saying in the null hypothesis, but it still is not sufficient. And is it sufficient or not? That will be obviously revealed after we have performed the test. So we go on and do our computations. So before that we have like assumptions that we are undergoing. Sample of the cartwheel distance measurements considered a simple random sample. तो हम simply ये assume कर रहे हैं कि okay, जो हमने data collect किया है जो हमारा sample है वो एक simple random sample है. अब यहाँ आपको एक और चीज़ भी interesting observe करने को मिलेगी कि एक सेटिंग ऐसी हो सकती है, एक सोशल सेटिंग ऐसी हो सकती है जिसमें कार्ट व्हील परफॉर्म करना एक आम रेगुलर एक्टिविटी है, और कोई दूसरी सेटिंग ऐसी हो सकती है जिसमें कार्ट व्हील परफॉर्म करना एक बिल्कुल एक्सेप्शनल एक्टिविटी है. लाइक हमारी सेटिंग्स के अंदर easily more than 95% of the people are not even aware what do we mean by cartwheel. So it will be very different. For example, if I try to perform a cartwheel, I might only be able to cover say like nothing kind of a distance, right? So I don't know. So basically जब हम random samples की बात करते हैं तो देर इज हम एक जो रैंडम सैंपल हमने लिया है उस रैंडम सैंपल के स्टेटिस्टिक्स को देखकर हम उसको किस हद तक सारी पॉपुलेशन के लिए जनरलाइज कर सकते हैं, ये है अहम सवाल. ये सारा जो हम हाइपोथेसिस टेस्ट कर रहे हैं या कॉन्फिडेंस इंटरवल्स कंस्ट्रक्ट करते हैं तो प्राइमरीली इस वजह से करते हैं कि हम इस चीज़ को इंश्योर करना चाहते हैं कि एक सिंपल रैंडम सैंपल की बेसिस के ऊपर जो कंप्यूटेशन हमने की है वो किस हद तक सारी पॉपुलेशन के लिए जनरलाइज की जा सकती है. सो दैट कैन बी very different. Okay, so we assume that the sample of the cartwheel distance measurements is simple random sample and the normal distribution of cartwheel distance in population. और हम ये भी assume कर रहे हैं कि जो distribution है वो normal है, right? So that aspect is not as critical if we have large enough sample size, but still let's graph our data. We have only 25 values here. Now if we look at this this graph, histogram and normal QQ plot. So as I said earlier that we have not explained what QQ plots are, but simply stating QQ plot का purpose basically ये होता है कि अगर आपका data normally distributed है तो आपके सारे data points जो होंगे वो diagonal line के ऊपर आ रहे होंगे. सो जितना ज़्यादा डायगोनल लाइन से आपके पॉइंट्स अवे होंगे हम उतना ही एज्यूम करेंगे कि आपका डेटा नॉर्मली डिस्ट्रीब्यूटेड नहीं है. अच्छा, अब इस केस में देखें तो इट लुक्स लाइक दैट देयर इज वन साइड ऑफ द डेटा मिसिंग, लाइक दैट शुड बी हियर. इधर जो डेटा हो सकता था वो शायद मिसिंग है, एंड दिस डेटा इज लाइक गोइंग डाउन लाइक दिस. सो इट इज फ्रॉम दिस एंड नॉर्मली डिस्ट्रीब्यूटेड, right? And if you look at like this QQ plot, तो इस QQ plot के ऊपर भी हमें नजर आ रहा है कि yes, data is not exactly aligned on जी
सुने आप, ये इधर शादमान वाले ऑफिस में है ना?
जी जी.
अच्छा, आपका खाना ला रही हूँ, बेटे पे जाओ.
खाना भले क्या क्या है, क्या लेके आ रही हैं आप अभी?
बस लेके आ रही हैं, मैं पहुंच गई हूँ.
अच्छा, ओके. this is obviously not exactly aligned with the diagonal line, but we say that it is not also very much away. So we again go with the assumption that the central limit theorem will help us here, and if we like keep drawing the samples, we will ultimately be approaching the normal distribution. So let's go ahead and go on with the formulation. So, is sample mean of 82.48 inches significantly greater than hypothesized mean of 80 inches? अब हम ये कहते हैं कि जो सैंपल का मीन हमें मिला है 82.48 इंचेस, जो जाहिर है कि बज़ाहिर हाइपोथेसाइज्ड मीन से ज़्यादा है जो कि सिर्फ 80 इंचेस था, लेकिन क्या ये सिग्निफिकेंटली ज़्यादा है? So this is what we need to test now. अब हमें मालूम है standard error of the sample mean would be the standard deviation divided by the square root of n, and the estimated standard error on the sample would be the standard deviation. ज़रा हमारे पास population का standard deviation तो नहीं है, so we have the standard deviation from the sample only, so we will be dividing that sample standard deviation with the square root of n to find the value of the estimated standard error in this case. So now we put these values in our test statistic formula, that is the best estimate minus the null value. So that is x bar minus 80, and x bar is 82.48. So we will have 82.48 minus 80 divided by the sample standard deviation, which is 15.06, and we divide that further with the square root of the size of the sample, which is 25. Square root of 25, that will be 5. So the value that we ultimately get is 2.48 over 3.012, which is 0.82, right? Now again I leave this to you. How do you interpret this 0.82? Let's hold again. Okay, so what do you make of this 0.82? How do you interpret this 0.82? We have done it a number of times. That what does it mean? So this 0.82 basically means that our sample mean is only 0.82 standard errors above the null value of 80 inches, right? So this value is obviously for the error, right? So हम ये कहेंगे कि हम और ये positive है, so obviously this is 0.82 standard errors greater than the value for the null hypothesis, right? That's how we interpret it. Is it significant enough, right? Now we need to determine the p-value for that. So if null hypothesis was true, would a test statistic value of only 0.82 be unusual enough to reject the null? So obviously that basically depends on कि हमें इसके against p value क्या मिलती है. Now the p-value basically is the probability of seeing the test statistics of 0.82 or more extreme, assuming the null hypothesis is true, right? So if the null hypothesis was true, t-test statistic follows a student t distribution with degree of freedom. n minus 1 which is 25 minus 1 or equal to 24. So basically हमने ये बात पहले कही थी कि जब हम नॉर्मल डिस्ट्रीब्यूशन की बात कर रहे होते हैं और उसके बाद हम एस्टिमेट कर रहे होते हैं मीन को, सो फॉर द सेक ऑफ सम स्टैटिस्टिकल रेगुलरिटीज हम फिर उसको नॉर्मल डिस्ट्रीब्यूशन की बजाय स्टूडेंट टी डिस्ट्रीब्यूशन के ऊपर फॉर्मुलेट करते हैं, और उसमें जब आप स्टैंडर्ड डिविएशंस जो हैं सैम्पल्स की उनका सम करते हैं तो अल्टीमेटली दे टर्न आउट टू बी zero. So if we know the standard deviation of n minus 1 samples, we can tell what will be the standard deviation for the nth sample in that case. So that will be n minus 1 की standard deviations को sum करें और 0 से जितना difference बाकी बचता है वो उसमें add करें, तो that will be ultimately 0. That's why we say that is has a degree of freedom of n minus 1. So since we have one tail test to the right, सो हाँ, अब हमारा जो टेस्ट है वो सिंपलर है बिकॉज बेसिकली वी आर सेइंग, अगर आपको पिछली एग्जांपल याद हो तो पिछली एग्जांपल में बेसिकली हमारा जो नल हाइपोथेसिस था वो था P1 हैट माइनस P2 हैट इक्वल ज़ीरो, राइट. सो इफ वी लाइक सी इट हियर तो so we had this hypothesis. S naught was P1 minus P2 is equal to 0 and alternative was P1 minus P2 not equal to 0. इस केस में क्या है? We have mu equals 80 and mu greater than 80. राइट. अच्छा, जब आप नॉट इक्वल की बात कर रहे होते हैं तो फिर आपको दोनों साइड्स चेक करनी होती हैं, क्योंकि आपको लेस देन और ग्रेटर देन दोनों चीज़ें रेलिवेंट हैं. अगर आपके अल्टरनेट हाइपोथेसिस में आपके पैरामीटर ऑफ इंटरेस्ट की वैल्यू सिग्निफिकेंटली लेस है नल हाइपोथेसिस के निस्बत तो भी वो क्वालिफाई करता है, और अगर सिग्निफिकेंटली ज़्यादा है तो भी वो क्वालिफाई करता है, राइट. सो नॉट इक्वल के केस में आपको दोनों साइड्स देखनी होती हैं, लेकिन इक्वल के केस में, नॉट इक्वल के केस में, लेकिन जब आप डायरेक्शन तय कर देते हैं कि नहीं ग्रेटर देखना है तो इसका मतलब है कि आप फॉर एग्जांपल उसकी राइट साइड के अंदर इंटरेस्टेड हैं, वन साइड ऑफ द टेल. सो बेसिकली डिस्ट्रीब्यूशंस की टेल का मतलब ये होता है कि दे आर फॉर एग्जांपल राइजिंग फ्रॉम वन साइड एंड दे आर एंडिंग ऑन द अदर साइड, सो दे हैव काइंड ऑफ टू टेल्स. सो फ्रॉम दैट वी आर चूजिंग वन टेल व्हिच इज द राइट वन इन दिस केस. Okay, so basically, this is what we mean by it now, right? So students T distribution based on that, जब हम इसको normal distribution के तौर पे curve में लेते हैं 0 2 4 like this, it goes on like that. So this is the point where we have point 82. And since we are talking about greater than value, so that means we are only interested in one side. अगर हम greater की बजाय not equal की बात कर रहे होते तो फिर हम minus 0.82 भी लेते हैं यहाँ पे, राइट. और ये एरिया जो है इस एरिया को भी इसके साथ मेजर करते हैं, राइट. सो वी आर ओनली इंटरेस्टेड इन दिस साइड and we will be like looking at the value for this. So the p value for this particular 0.82 test statistic turns out to be 0.21. If population mean cartwheel distance was really 80 inches, then observing a sample mean of 82.48 inches, that is the t statistic of 0.82 or larger is quite likely, right. अब इसका मतलब क्या है? Can anybody interpret this? That we have got a p value of 0.21 and we have like written a statement to explain this a bit. Just read through this statement and try to understand कि ये statement क्या कहने की कोशिश कर रही है. Is it kind of making our believe that we should reject the null hypothesis and go with the alternative, or what? Gee, anybody? शुड आई आस्क अगेन, आप लोगों को आवाज आ रही है मेरी? तो आप इस बात पे कोई राय नहीं देना चाहेंगे? You don't get this sentence? So what we are saying here is that, okay, for the test statistic we had the value of 0.82 and the associated p-value with that 0.82 is 0.21 that we will get from the table or the any available repository to tell the values for p-values for this test statistic. अब इस p-value का मतलब क्या है? If population mean cartwheel distance was really 80 inches, अगर हम ये कहें कि जी population जो है उसका असल में जो mean distance है वो 80 है, then observing a sample mean of 82.48 inches is or larger is quite likely. So basically इसका मतलब ये है कि अगर आपकी population में cart wheel का distance असल में 80 ही है, we don't know what it is but just we assume कि फर्ज करें कि वो वाकई 80 है, तो अगर आप कोई सैंपल रैंडम सैंपल कलेक्ट करेंगे और उसमें अगर आपकी वैल्यू 82.48 इंचेस मीन के तौर पे आ जाए, it's perfectly okay. We can always expect that if the population mean is 80, the sample mean can be 82.48. यानी इसका मतलब बेसिकली ये है कि इतनी वेरिएशन एक्सपेक्ट करना परफेक्टली ओके है हमारे लिए। और इसका अगला मतलब ये है कि महज इतने फर्क की बेसिस के ऊपर हम अपने नल हाइपोथेसिस को रिजेक्ट नहीं कर सकते। So since our p-value is much bigger than 0.05 significance level, weak evidence against the null, so that means we fail to reject the null. Based on estimated mean, we cannot support the population mean cartwheel distance is greater than 80 inches. यार ये डिफरेंट वीडियो फिर आ गया है। Okay. So based on estimated mean of 82.48 inches, we cannot support the population mean cartwheel distance is greater than 80 inches. So इस बुनियाद पर हम ये नहीं कह सकते कि हमारा जो एस्टिमेटेड मीन है वो 82.48 इंचेस है और जो हमारे पास नल हाइपोथेसिस में मीन था दैट वाज अवेलेबल टू अस वाज 80, so we can say that it is significantly larger. We say that okay, it's pretty much like that for one sample if you have got 82, for another sample you might get a mean of 78. So like this much is not that bigger of a difference, so we cannot simply reject the null hypothesis based on this much of the variation. We need something more significant. An alternative to this would be कि हम इसी चीज़ को बेसिकली कॉन्फिडेंस इंटरवल से भी कर सकते हैं। हम ये करते हैं कि हम इसका 90% कॉन्फिडेंस इंटरवल जो है वो एस्टिमेट करते हैं। सो वी नो दैट द मीन इज 82.48, द स्टैंडर्ड डेविएशन इज 15.08 एंड द ऑब्जर्वेशंस आर 25 and the t value for number of observations 25 is 1.71, and we say that okay, we use this formula x bar plus minus t into s over square root of n, and we plug in the values, and the range for this 90% confidence interval that we get is 77.3 inches to 87.63 inches, right? अब ये कॉन्फिडेंस इंटरवल हमारी प्रीवियस कंक्लूजन को कैसे सपोर्ट करता है? वी सी दैट 80 इंचेस इज in confidence interval of reasonable values for population mean cartwheel distance. अब हमारे पास मीन था 82.48 और इसकी बेसिस के ऊपर जब हमने 90% कॉन्फिडेंस इंटरवल कंस्ट्रक्ट किया तो हमें पता चला कि हमारी रेंज ऑफ रीजनेबल वैल्यूज फॉर द मीन इन पॉपुलेशन टर्न्स आउट टू बी फ्रॉम 77.30 टू 87.63। यानी इसका मतलब ये है कि हम 90% कॉन्फिडेंस के साथ ये कह सकते हैं कि अगर हम ये सैंपल बार बार ड्रॉ करें तो हमारी वैल्यू इस रेंज के अंदर फॉल करेगी और 80 इंचेस इस रेंज का हिस्सा है। सो दैट मीन्स कि इसकी बेसिस के ऊपर हम ये नहीं कह सकते कि हमारा जो एवरेज कार्टव्हील डिस्टेंस है पॉपुलेशन में वो 80 से ज़्यादा है. इट कुड बी लाइक विद दिस कॉन्फिडेंस इंटरवल दिस कुड बी एनीवेयर बिटवीन 77 एंड 87. You get this point? You get this point? Boys, girls, you get this point that I've just mentioned? There's so many people. Abdurrahman, Amna, Ansar, Arij, Faraz, Fasih, Fiza, Hamad, Hamna, Hashir, Hasnan, Humaira, anybody. Did you get the point that I just explained to you? Okay. All those who got this point should say yes. Okay, Mujib. Anybody else? ओके. तो आंसर आप इस बात को अपने लफ्ज़ों में थोड़ा एक्सप्लेन कर सकते हैं दोबारा जो बात हमने अभी कही. आंसर आपको आवाज़ आ रही है? आंसर आपको हमारी आवाज़ आ रही है? आपकी आवाज़ हमें नहीं आ रही. ओके आमना, आप इसको एक्सप्लेन कर सकती हैं व्हाट वी हैव जस्ट सेड? प्लीज गो अहेड. जी जी. ओके. So what do we conclude out of it about our hypothesis? Since the null hypothesis is included in this, so there isn't sufficient evidence for us to reject that null hypothesis then. So 80 is in this interval already. So this is another way of testing the same thing. Now, what if normality doesn't hold? हम लाइक डेटा को देखते हैं एंड somehow we are not convinced that the normality holds. So we are not convinced that cartwheel distance follows a normal distribution in the population. So if we are really concerned about the distribution, then we can do something like non-parametric test that does not assume normality. सो लाइक अभी तक जितना भी हम काम कर रहे हैं वो ये अज्यूम करता है कि डेटा नॉर्मली डिस्ट्रीब्यूटेड है. सो अगर हमें ये बात बहुत ज़्यादा क्वेश्चनेबल लगती है एंड इफ़ यू अज्यूम दैट द डेटा इज़ नॉट नॉर्मली डिस्ट्रीब्यूटेड, we can go on with some other kind of test known as the non-parametric test. And the non-parametric analog of the one sample t test is basically Wilcoxon signed rank test, which basically uses median to examine location of distribution of measurements rather than mean. तो विल्कॉक्सन टेस्ट क्या होता है हम इसको तो डिस्कस नहीं करेंगे, लेकिन एक सिंपल सा डिफरेंस हम यहाँ ये बयान कर सकते हैं कि हम पॉपुलेशन के मीन की बजाय मीडियन पे इस चीज़ को मैयर करेंगे विल्कॉक्सन टेस्ट अगर हम परफॉर्म करते हैं. सो यू नो द डिफरेंस बिटवीन मीन एंड मीडियन. Anybody who can tell the difference between mean and median? Nobody is telling the difference between mean and median. Okay. So Wilcoxon assigned rank test basically gives us the p-value of 0.05. We haven't really shown the measurement here, but we just to like go on with it. We have shown the value p-value for that, and again based on this value, we fail to reject the null that population median cartwheel distance of 80 inches. So conclusion is robust to potential violations of normality. So the population of interest, regardless of assumptions made and inference approach used, there is not sufficient evidence to support that the population mean cartwheel distance is more than 80 inches. हमने इसको रेगुलर अप्रोच से करके भी देखा, फिर हमने इसको ये अज्यूम करते हुए कि शायद नॉर्मल सी टेस्ट कोई बहुत अच्छा नहीं था हमारा, तो हमने इसको एक अल्टरनेटिव अप्रोच यानी विल्कॉक्सन साइन रैंक टेस्ट के जरिए पीपी वैल्यू को कंप्यूट करके देखा. वी सॉ दैट इन बोथ केसेस we do not find sufficient evidence to reject the null hypothesis. So in summary, hypothesis tests are used to put the theories about a parameter of interest to the test. And the parameter, for example, is the population mean. The basic steps are to state the hypothesis, examine the results, check the assumptions, and then convert and then summarize via test statistic. Convert test statistic to p-value and compare p-value to significance level to make the decision. Right. So assumptions for one sample test for the population mean are that data considered is the random sample and the population of responses is normally distributed or is at least large enough. Uh, okay, Ji. Now the last thing that we will see today is the last thing that we will see today is the testing a population. Okay, you have 10 minutes off now. Okay, Ji, we begin from where we left off. So in this last example, we will be testing a population mean difference. So again, the sequence was the same that we started with proportion, then proportion difference, then mean, and now we will be talking about the mean difference. So like we have 20 homes remodeling their kitchens, requesting cabinet codes from two suppliers. Is there an average difference in cabinet codes from these two suppliers? So now we have kind of paired data here, and the variable of interest is different in the cabinet codes, the prices that they give between supplier A and supplier B, right? So we have kind of 20 items, data items here, where we have the values coming from supplier A, the values coming from supplier B, and then we note the difference of those and we take the mean of those, both of those. Now, is there an average difference between the cabinet codes from the supplier? This is the research question that we face. Is there an average difference between the cabinet codes from the supplier? So the population is all houses, basically all houses looking to renovate or requesting the codes, right? And the parameter of interest is population mean difference of cabinet codes, right? So we will call it mu d, then the difference between G. Sorry, boys, you should tell quickly. I often forget things as well. Okay, so we start over again. We have data from 20 homes remodeling their kitchens, requesting cabinet codes from two suppliers, and we need to see is there an average difference in cabinet quotes from these two suppliers. So 20 घर हैं जो अपने किचन को रीमॉडल करना चाहते हैं, वो दो डिफरेंट सप्लायर्स से कोट्स लेते हैं कैबिनेट्स परचेज करने के लिए, एंड we want to notice that is there an average difference in cabinet quotes from these two suppliers. The research question is there an average difference between the cabinet quotes from the suppliers? The population is all such houses which are interested in the renovation or taking the quotes on the cabinets, and the parameter of interest is population mean difference of cabinet quotes, mu of d, between supplier A and supplier B. And now test for significant mean difference in cabinet quotes at the 5% significance level. अब हम देखना ये चाहते हैं कि क्या जो दोनों सप्लायर्स ने प्राइसेस कोट की हैं उनमें एक सिग्निफिकेंट मीन डिफरेंस है या नहीं, एंड वी यूज 5% सिग्निफिकेंस लेवल इन दिस केस. Our null hypothesis is that the mean difference in the prices quoted by two suppliers is negligible, or there is no difference, so the difference is zero. And the alternative hypothesis is that no, this difference is not zero, there is some kind of significant difference between the two, and the significance level that we have decided for our test is 5%. So here is the data on the display. So like the value from the supplier A for a cabinet is 380 and from the supplier B is 325. So there is a difference of $55 in that price, right? And similarly, we can look at this difference column all the way down, and we can see that for the second case, there is a difference of $90. The supplier A is $90 expensive, and for the last case, the supplier A is $56 expensive, and for the second last case, supplier B is $6 expensive. So generally looking at this data, हमें ये चीज़ नज़र आ रही है कि जो supplier A की quoted prices हैं for the cabinets, वो supplier B की quoted prices के मुकाबले में कदरे ज़्यादा हैं, and in general वो difference visibly हमें नज़र आ रहा है. There is only one case that we see here in which supplier B is quoting more price, and that is very like minimum of the difference. So this is kind of like we have plotted these values on two dimensions, right, to see the difference. So they are more tilted towards supplier A. Now let's first talk about the assumptions. We need to assume that we have a simple random sample, right? So we say, okay, we are having the data that we have is coming from a simple random sample. We simply assume that, and we also need the population differences to be normally distributed. So we can get around this assumption if we have large sample size, about 25 plus or so, right? Now in this case, we have data of the sample size is only 20, right? So again, we are taking a bit of leverage, और हम ये assume कर रहे हैं that okay, 20 is probably good enough for us. Had it been more, it would have been obviously better. Okay. So we need to assume that we have random sample sample of differences, that is random sample of houses. We also need the population of differences to be normally distributed. We can get around this assumption if we have big enough data size, which as in this case we said that we have 20 items. So we say, okay, it is there or thereabout. But we see it simply on the QQ plot, right? So as we see it on the QQ plot, the data is basically not exactly on the diagonal, right? It's like going this way, and this way. So there is a slight skew, but it isn't at least like this, that there is a point here, there's a point here, there is a point here, or the trend is something like this. There is a very weird kind of trend, like this. So we say, okay, it is somewhat aligned with the and now if we look at this data, so we say, okay, not exactly, but it is not far away from the normal distribution. If we look at the histogram, so this looks like relatively normally distributed. So we have only 20 observations in this, and the minimum difference that we note here is 30, and the maximum difference that we note here is 90. The median is 13.5 and the mean is 17.3, right? And the standard deviation is 28.49. So deviation is relatively high in this case. Now, assuming the sample distribution of sample mean difference is normal, we go on with our test statistics. The t in this case, it was z for the proportions and t for the mean. So we have like best estimate minus hypothesized estimate divided by the estimated standard error of estimate. So best estimate हमारा क्या है? On mean, that is 17.30. और hypothesized estimate हमारा क्या है? This is our hypothesized estimate, which is 0, right? So this should be like best estimate should be 17.30 and the hypothesized estimate should be only 0. So it should be 17.30 minus 0 divided by the standard deviation, which is 28.49, and that will be divided by the square root of 20, which is the sample size for us. And the value that we compute based on that is 2.72. Now, what does this value 2.72 mean, and what do we need to measure out of it to get the value of p? So our observed mean difference is 2.72 standard errors or estimated standard errors above our null value of 0. तो हमने null hypothesis में assume किया था that there is no difference. And now we see that when we compute the test statistics, it is 2.72 estimated standard errors higher than the null hypothesis. And now we need to see that how significant it is by transforming this into the p-value. So the p-value with a degree of freedom of 19, because we have 20 items in it, so the degree of freedom will be 19 in this for the normal distribution. Will be like, basically, again, if you see, so we will be like trying to estimate something like this again, right? And the 0 will be somewhere here. 1, 2, 3. So it is 1, it is 3. And similarly, this will be -1, -2, and -3. Right? And we need to see that we have 2.72. The 2.72 is somewhere here, so it's like this. And since again the case is of inequality, so that means we will be measuring it from both sides. हम दोनों sides से इसको measure कर रहे होंगे, right? Like this, right? So this region here and this region here will get measured in this case, right? अगर ग्रेटर देन हो तो हम सिर्फ राइट साइड पे जाएंगे, लेस देन हो तो हम सिर्फ लेफ्ट साइड पे जाएंगे, और अगर नॉट इक्वल है तो हम दोनों साइड्स को मेजर करते हैं, राइट? सो दैट्स व्हाट वी आर इंटरेस्टेड इन अल्टीमेटली. So the p-value that we get in this case is 0.014, which is less than 0.05, which was the level of significance that we associated with the computation of the interval of the hypothesis, to test the hypothesis. That means the p-value less than alpha means that we can reject the null hypothesis now. So we have evidence, or enough evidence, against mean difference in cabinet codes is 0. So formally, based on our sample and our p-value, we reject the null hypothesis. We conclude that the mean difference of cabinet code prices for supplier A less G. Okay. So we conclude that the mean difference of cabinet prices quoted from supplier A and B is significantly different from 0 based on the hypothesis that we have tested. We can cross test it by constructing the 95% confidence interval because we had the significance of 5%. So we construct 95% confidence interval. Had we got the significance of like 10%, we would have constructed the 90% confidence interval to test the same thing. So the mean in this case is, for example, 17.30. Standard deviation is this. And for 20 observations, the value of t would be 2.093. And once we plug in these values in this formula to test, uh, like the confidence interval construct करने के लिए, so we plug in all these values, and the range of reasonable values that we get in this case basically start from $3.97 and at $30.63. Now note that 0 is not in our range of reasonable values for mean difference in cabinet prices, right? So अगर for example ये interval माइनस से शुरू होकर किसी पॉजिटिव वैल्यू में जाता, तो दैट मीन्स कि इसके अंदर जीरो इंक्लूडेड होता है. जीरो इज नॉट इंक्लूडेड इन दिस, सो दैट मीन्स वी कैन से that we can reject the null hypothesis because there is some significant difference in the mean prices quoted by both the suppliers. And again, we say the same thing. If normality doesn't hold, we can use the Wilcoxon signed rank test to test the value of the median. And for that, it turns out to be 0.020. And again, we can reject the null hypothesis and conclude that the mean difference in the cabinet codes is different from 0. So hypothesis tests allow you to assess theories about a population parameter of interest, right? For example, in this case, the parameter was mean difference. An extension of one mean hypothesis test, और इसमें हमने extension क्या की कि हमने difference variable को लिया, right? And this time it is collected on the same individual, so we say it is basically the paired data and can obtain similar information from confidence interval that Wilcoxon signed rank test. That basically makes our results more credible. Okay G, so that's it for the day. If you have any questions, do let me know. Any questions? None. Okay, then see you next week, inshallah, at the same time at 3 o'clock, 3 p.m. on next Wednesday. Yeah, if it is physical, fair enough. अगर physical नहीं होती तो हम online, यानी हम इस वक्त online class ले रहे हैं तो हमारा schedule यही है. अगर next week university खुल जाती है इंशाल्लाह तो obviously we will go back to the physical class, right? Okay then, Allah Hafiz.